Hello friends, in this lecture of computer networks we are going to discuss about OSI reference model. What is an OSI reference model? First of all, what is the full form of OSI? OSI stands for Open Systems Interconnection. OSI is a reference model. It is a conceptual framework used to understand and standardize the functions of a telecommunication or computing system without regard to its underlying internal structure and technology. OSI model consists of 7 layers. Now what are the 7 layers? First layer is physical layer. What does physical layer do? Physical layer defines the physical means of transmitting data between devices. Second layer is data link layer. It provides error-free transfer of data frames between two devices on the same network. Third layer is network layer. What does network layer do? It routes data between different networks. Now the fourth layer is transport layer. It provides reliable data transfer between devices. Fifth one is session layer. It establishes, manages and terminates connection between applications. Sixth layer is presentation layer. It converts data into a format that can be understood by the receiving device. And the seventh and the last layer is application layer. Application layer provides services to end user application. We will see some example use case. When you send an email, the data flows each layer of the OSI model. You compose the email in the application layer. The email is formatted and encoded in the presentation layer. A connection is established with the email server in the session layer. The email is transmitted reliably over the network in the transport layer. Now the email is routed to the recipient's network in the network layer. After that, the email is transmitted over the physical medium in the data link layer and the physical layer. Understanding the OSI reference model helps us to design and troubleshoot complex systems. Next topic we are going to discuss is TCP or IP model. Now what does TCP or IP stands for? Transmission Control Protocol or Internet Protocol. The TCP or IP model is a conceptual framework used to understand and standardize the functions of the Internet Protocol suite. It is a simplified version of the OSI reference model with a focus on the protocols used in the Internet. Now this TCP or IP protocol consists of 4 layers. What are the 4 layers? First layer is the application layer. It provides services to end user applications such as email, file transfer and web browsing. Second layer is transport layer. It provides reliable data transfer between devices using protocols such as TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. Third layer is Internet Protocol. It routes data between different networks using protocols such as IP, Internet Protocol. Fourth layer is Network Access Layer. It combines the functions of the OSI model's data link layer and physical layer, defining how devices access the network. Some key protocols in TCP or IP model. First one is Transmission Control Protocol, a connection-oriented protocol that ensures reliable data transfer. Next is UDP, User Datagram Protocol, a connectionless protocol that provides fast but unreliable data transfer. Internet protocol, a protocol that routes data between networks. Hypertext transfer protocol, a protocol that governs communication between web servers and clients. File transfer protocol, a protocol that governs file transfer between devices. We will see example use case of transfer control protocol. Transmission control protocol. When you request a website, the data flows through each layer of the TCP or IP model. You enter the URL in the application layer. The request is transmitted reliably over the network using TCP in the transport layer. The request is routed to the web server's network using IP in the internet layer. The request is transmitted over the physical medium using Ethernet or Wi-Fi in the network access layer. Now we will compare OSI model and TCP or IP model. The TCP or IP model is similar to the OSI model but with some key differences. What are the differences? The TCP or IP model combines the OSI model session layer, presentation layer and application layer into a single application layer. The TCP or IP model combines the OSI model's data link layer and physical layer into a single network access layer. These are some differences between TCP IP model and OSI model. Transmission modes. Transmission modes refer to the way data is transmitted between devices over a communication channel. There are several transmission modes, each with its own characteristics and advantages. First is simplex mode. In simplex mode, data is transmitted in one direction only, from the transmitter to the receiver. The receiver cannot send data back to the transmitter. Example, radio broadcasting, where the radio station transmits audio signals to listeners, but listeners cannot send signals back to the station. Half duplex mode. In half duplex mode, data is transmitted in both directions, but not simultaneously. The transmitter and receiver take turns sending and receiving data. Example is walkie-talkies, where one person speaks and other listens, then the roles are reversed. Third is full duplex mode. In full duplex mode, data is transmitted in both directions simultaneously. The transmitter and receiver can send and receive data at the same time. Example is telephone conversations, where both parties can speak and listen at the same time. Fourth is asynchronous mode. In asynchronous mode, data is transmitted in a start-stop manner, with each byte or character transmitted separately. Example is serial communication, where data is transmitted one byte at a time, with a start bit, data bits and stop bits. Fifth is synchronous mode. In synchronous mode, data is transmitted in a continuous stream with a clock signal used to synchronize the transmitter and receiver. Example is Ethernet networks, where data is transmitted in a continuous stream with a clock signal used to synchronize the devices. Sixth is unicast mode. What is unicast mode? In unicast mode, data is transmitted from one device to another device with the data intended for a single recipient. Example, email, where a message is sent from one person to another person. Seventh is multicast mode. In multicast mode, data is transmitted from one device to multiple devices with the data intended for a group of recipients. Example, video conferencing, where a video stream is sent to multiple participants. 8th is broadcast mode. In broadcast mode, data is transmitted from one device to all devices on a network, with the data intended for all recipients. Example, network announcements, where a message is sent to all devices on a network. Now we will revise this modes, and we will also see advantages and disadvantages of these modes. First was simplex mode. In that, one-way transmission was done. What are the advantages? It is low cost and it has simple implementation. What are the disadvantages? In simplex, no feedback and limited functionality is there. Next is half duplex. In half duplex, two-way transmission takes place. What are the advantages of half duplex? It is low cost and simple implementation. What are the disadvantages? It has limited functionality and it gives a delay. Next is full duplex. In this, we saw it is two-way transmission, that too simultaneous. Advantages are high speed transmission and it is efficient. What are the disadvantages? Higher cost and complex implementation. Next is asynchronous. In this, start stop transmission takes place. What are the advantages? Low cost, simple implementation. And what are the disadvantages? It is limited speed and it is error prone. Next is synchronous. It is a continuous transmission. What are the advantages? High speed transmission and it is efficient. What are the disadvantages? Higher cost, complex implementation. Next is unicast. It is one-to-one transmission. What are the advantages? It is secure and it is efficient. But what are the disadvantages? Limited scalability. Multicast. Next is multicast. In multicast, one-to-many transmission takes place. In this, what are the advantages? It is efficient and it is scalable. What are the disadvantages? It is complex implementation and it has limited control. We cannot control it properly or completely. Next is broadcast. In broadcast, one-to-all transmission is done. In this, simple advantages is simple implementation and it is efficient. What are the disadvantages? Limited control, security concerns. Hello friends, welcome back. In this lecture we are going to discuss network topologies. Network topologies refer to the physical and logical arrangement of devices and connections within a computer network. Network topologies refer to physical and logical arrangement of what? Devices and connections within a computer network. Now there are several types of network topologies. Each of them has their own advantages. First one we are going to learn is bus topology. In bus topology, all devices are connected to a single cable that runs from one end of the network to the other. Second one is star topology. In a star topology, all devices are connected to a central device, hub or switch, that acts as a connection point. Next is ring topology. In a ring topology, devices are connected in a circular configuration and data travels in one direction around the ring. Next is mesh topology. In a mesh topology, each device is connected to every other device. All devices are connected to each other, providing multiple paths for data transmission. Next is tree topology. We also call it as hierarchical topology. In tree topology, devices are connected in a hierarchical structure with multiple levels of connections. Next is hybrid topology. In hybrid topology, two or more different topologies are combined to create a network. Now we are going to see advantages and disadvantages of these different topologies. First was bus topology. Advantages are it is simple and it has low cost. Disadvantages are single point of failure, difficult to troubleshoot. Next is star topology. It is easy to install, it is easy to maintain and troubleshoot. What are the disadvantages? Central device failure may occur and it is more expensive. Next is ring topology. What are the advantages of ring topology? High speed data transfer and fault tolerance. What are the disadvantages? Difficult to install, single point of failure. Next is mesh topology. What are the advantages of mesh topology? It is more reliable and it has fault tolerance. What are the disadvantages of mesh topology? It is more expensive and it is complex to install. Next is tree topology. It combines benefits of bus and star, easy to install. But what are the disadvantages? It is difficult to troubleshoot and it has central device failure. Next is hybrid topology. In hybrid topology, it combines benefits of multiple topologies and it is flexible. But it is complex to design and it requires careful planning. Hello friends, welcome back. In this video, we are going to discuss ways to measure network performance. So, what are the fundamental ways which we use to measure the network performance? First is throughput, second is latency, third is jitter, fourth is packet loss, fifth is network utilization. Now, what is throughput? Throughput measures the amount of data that is successfully transmitted over a network in a given amount of time, usually measured in bits per second, BPS. It's a measure of how much data is being sent and received over the network. Throughput is equal to total amount of data transferred divided by time taken to transfer. Throughput is very important. It is essential for applications that require high speed data transfer, such as video streaming, online gaming and file sharing. Next is latency. Latency measures the delay between the time data is sent and the time it is received. The delay between the time data is sent and the time data is received. It's a measure of how long it takes for data to travel from sender to receiver. Latency is equals to time taken for data to travel from sender to receiver. Latency is crucial for real-time applications such as video conferencing, voice over IP, and online gaming, where delays can affect the user experience. Next is jitter. Jitter measures the variation in latency over time. It's a measure of how consistent the latency is. Jitter is equal to maximum latency minus minimum latency by 2. Jitter is important for applications that require consistent latency such as video streaming and VoIP. Next is packet loss. Packet loss measures the percentage of packets that are lost or corrupted during transmission. Packet loss is crucial for applications that require reliable data transfer such as file transfer and email. Next is network utilization. Network utilization measures the percentage of available network bandwidth that is being used. Network utilization is equal to total bandwidth used by total available bandwidth into 100. Network utilization is essential for network administrators to ensure that the network is not overloaded, which can lead to performance issues. These 5 fundamental metrics are essential for measuring network performance. By monitoring and analyzing these metrics, network administrators can identify performance issues, optimize network configuration, and ensure that the network is running efficiently and effectively. Thank you. Hello friends. In this video we are going to discuss why protocols are needed in computer networking. What are its importance? So, protocols are essential in computer networking for several reasons. First is standardization. Second is interoperability. Third is efficient data transfer. Fourth is error detection and correction. Fifth, security. Sixth, scalability. Seventh is reliability. Eighth, quality of service. Ninth, network management. 10th, innovation. These are the reasons why protocols are important. First thing we saw is standardization. Protocols provide a common language and set of rules for devices to communicate with each other, ensuring that data is transmitted and received correctly, regardless of the device's manufacturer or operating system. This is standardization. Next is interoperability, which means protocols enable devices from different vendors to communicate with each other, allowing for seamless integration and compatibility between different systems and networks. Third is efficient data transfer. Protocols define the format and structure of data packets, ensuring that data is transmitted efficiently and reliably over the network. Fourth is error detection and correction. Protocols include mechanisms for detecting and correcting errors that may occur during data transmission, ensuring that data is delivered accurately and reliably. Fifth is security. Protocols provide a framework for implementing security measures such as encryption and authentication to protect data from unauthorized access or tampering. Next is reliability. Protocols ensure that data is delivered in the correct order and that there is no duplication or loss of data during transmission. Next is quality of service. Protocols enable networks to prioritize certain types of traffic, ensuring that critical applications receive sufficient bandwidth and low latency. Next is network management. Protocols provide a framework for managing and monitoring network performance, allowing administrators to troubleshoot issues and optimize network resources. Next is innovation. Protocols provide a foundation for innovation, enabling the development of new technologies and services that can be integrated into existing networks. Some examples of protocols are transmission control protocol, hypertext transfer protocol, file transfer protocol, secure shell, domain name system, dynamic host configuration protocol, simple mail transfer protocol. These are some of the examples of protocols. Now till now we discussed why protocols are important. Now we will discuss how network software is implemented in networks. Network software is implemented in networks through a combination of hardware and software components. What are the components? There are 4 main components: network operating system, network protocols, network services, network applications. Now, what are the implementation steps involved? that are first is hardware installation. Hardware is installed such as routers, switches and network interface cards are installed and configured. Next is NOS installation. NOS is installed on the network servers, which are typically high performance computers with specialized hardware and software configurations. Next is network protocol configuration. Network protocols such as TCP, IP are configured on the network devices including routers, switches and servers. Next is network service configuration. Network services such as FTP and email servers are configured on the network servers. Next is network application installation. Network applications such as web browsers and email clients are installed on the client devices such as laptops and desktops. Next is network configuration. The network is configured including setting up IP addresses, subnet masks and default gateways. Next is final step is testing and verification. The network is tested and verified to ensure that it is functioning correctly and that all network services and applications are working as expected. So these were the implementation steps for network software. How we implement network software in networks. These were the implementation steps. What were the steps? Hardware installation, NOS installation, network protocol configuration, network service configuration, network application installation, network configuration, testing and verification. Now we will see some network software implementation models. Some of them are client server model. Next is peer-to-peer model. Next is cloud computing model. In client server model, the network software is implemented on a centralized server and clients access the network services and application through the server. Centralized server is there and clients access the network services and application through that server. Next is peer-to-peer model. In peer-to-peer model, the network software is implemented on each device and devices communicate directly with each other without the need of a centralized server. Centralized server is not present. The network software is implemented on each device and each device communicate directly with each other. This is peer-to-peer model. Next is cloud computing model. In cloud computing model, the network software is implemented on a cloud-based infrastructure and devices access the network services and applications through the cloud. So devices access the network services and applications through the cloud. Cloud-based infrastructure is present. So this is cloud computing model. Thank you.